we are working today with our learning goal of I can identify quadratic functions and determine if they have a maximum or minimum. I'm going to be filling you with all kinds of information, and we have to try and, process through what a quadratic function, there's so much involved with it. So a quadratic function is any function, which means an equation, that can be written in the standard form y equals ax squared plus bx plus c. We should be used to this, an a, b, and a c. Quadratic trinomials, we've been factoring them. We've had an a, we've had a b, and we've had a c value. And a cannot equal 0. Because if we had an a value equal to 0, 0 times x squared would be what? 0. And then the x squared terms would be gone, and now we just have x's, and now it's become linear. So the a can't be equal to 0. B can be equal to 0. C can be equal to 0. But a cannot be, or we will not have a quadratic function. Okay, just like the linear family, the basic one in the quadratic family has a parent function so there's like a parent of the family. Anybody remember what the parent function is for the linear family? Y equals x. It's that basic. The most basic linear function there is. So what do you think might possibly be the parent function for the quadratic family? What do you suppose it looks like?
Y equals x squared.
Y equals x squared. So we need an x squared for it to be quadratic. The most basic, the parent function, has just a 1x squared. B was equal to 0, C was equal to 0, so A is equal to 1, B is equal to 0, and C is equal to 0. Once something happens so that that A value is no longer 1, but it's still not 0, and once something happens that that B value is no longer 0, and once something happens that that C value is no longer 0, they all play a role in it, and they help us be able to transform, we call it, the parent functions. Okay? Now, when you're going to really work with transformations the most is when you get to the next level of algebra class. So if in your senior year you take advanced algebra, you're going to do a lot of you're going to talk a lot about transformations. What happens to the parent function? So you need to kind of get a little bit of a handle on it right now. So the graph of 1 is a smooth curve called a parabola. Kind of looks like you would say a parabola, but it's parabola. Parabola sounds better. Parabola. Player N, could you join us, please? This is far more important than that. Okay, would you turn your calculators on now? Let's put one in. Let's see what the parent function for this one looks like. So turn it on and go to the press the y equals key. If there's anything in that screen, like y equals something, would you clear it out? Like when you get on, if y sub 1 equals has something behind it, just be on that one, press clear, and it should be there. I don't want you to have anything else in there right now. If any of those plots across the top, plot 1, plot 2, or plot 3 are darkened, cursor up, arrow up until you're on the plot that's darkened. Press the enter key, and it'll undarken it for you. So we have a plot 1, a plot 2, and a plot 3 that are not darkened. We have a y, we have a whole screen of y equals. By the way, cursor down, there's 10 places. Make sure there's nothing in it anywhere. Once you have everything cleaned out, undarkened, go back to y sub 1. And now you're going to press the x key, which is next to the alpha key. And then you're going to press the x squared key, which is going to square that x. And now your screen should read y equals x squared, right? All right? Okay, now I want you to do a zoom 6. There's a zoom key across the top. I want you to press zoom 6, and it's going to take care of a window for you. It's going to make a nice, what we call a window, and it should go to the graph for you. What kind of graph do you have? Is it a line? Kind of like a bowl. Is it V-shaped? Is it nice and V? No, it's a smooth curve. And this smooth curve is called a what? Parabola. Would you all practice saying that? It's so cool. This smooth curve is called a parabola. So quiet. Okay, it either opens up or it opens down. What's this one do? Opens up, right? It's opening up like this. Okay? So it's the A value. So let's go back to, just set that aside. You don't have to turn it off yet, but it's the A value that controls this. Remember, where's the A value at in our equation? In front of the what?
X squared.
In front of the x squared. So the A value controls this. When A is greater than 0, what's our A value for our parent function?
1.
1. And ours is opening what direction? Up. A is greater than 1. When A is 1, isn't that greater than 0?
Yes.
So when you have a positive A value, you can count on the parabola opening up. So let's go back into the y equals screen. Now let's try something. What would make it open down? Let's make an A value less than 0 and see if that's what does it. So go to the y sub 2 now. Let's just put another one in there. We'll have 2 of them on our picture at the same time. I want you to hit the negative key down at the bottom by the enter. It's in parentheses, not the subtraction key, the negative key. So do a negative, and then we're not going to have to put a 1 because we know that when we clean up an equation, we don't have the 1 there anyway. Go back and press the x key now, and the x squared key. And now your y sub 2 should read negative x squared.
The x key and the x squared?
Yeah, you got to do them both. The x squared does not put the x in for you, all it does is square it. So the x key is next to the L key. And then press graph, and you should have another parabola on there.
What came after the x squared?
Okay, first came the negative key,
Yep.
and then came the x key, and then came the x squared key, and then the graph. I had to walk myself through it, sorry. Graph key. Okay, what's happening with this new parabola?
It's just minor.
Oh, you're gonna go up and hold, no, press enter. There you go. What's it doing? So we got the one that's going up. Which one do you think that one is? The positive A value, right? The positive 1 A value. And now we put a new one in. So that one stayed there, didn't it? Because we didn't take it out of there. And the other one that's opening down has a negative A value. So when A is less than 0, it's going to open down. This is going to be something we want to remember. When A is greater than 0, when you have a positive value, your parabola should be opening up. Because you're going to graph these. And you better have a graph that matches what the equation says. So when you have a positive A value, your parabola better open up. When you have a negative A value, your parabola better open down. Will it ever turn sideways? No, not what we're going to do. No. Okay, that's a different thing. Okay, it changes direction at a point. Isn't there a place where the parabola, whether it's opening up or it's opening down, where it stops and kind of makes a turn? Look at the picture again on there. Is there some point that you could say, you know what? It appears right here. This is where it stops, and it starts to go the other direction. No? At 0, 0, right? At the origin for this one. Yeah. So we have this ordered pair. In this case, for this particular one, it's 0, 0. And this point is called a vertex. So where it makes its turn, we call that the vertex. So when the parabola opens up, we have that one, the y value of the vertex, which is what for this one? 0. That is called a minimum. It's the lowest y value on the graph. It is the y value that controls the minimum or the maximum thing. Could you join in here, Kelvin? We're filling our notes. So when the parabola opens up, the lowest point on the graph is that vertex where it turns, and the y value of that is called a minimum because the parabola doesn't go any lower than that. And remember, y values are the up and down, the higher and the lower. So it doesn't go any lower than that. When the parabola opens down, so look at the one that's opening down, it's the highest point of the one opening down. 0, 0 for this one, isn't it? What's the y value of that? What's the y value of that? 0, isn't it? Isn't it touching at the origin? So when it opens down, the y value of the vertex is called, what would the highest point be called? Not a minimum, but a maximum, yeah. Now, it should make sense if you really, put a visual together. When the parabola is opening up, can it have a maximum? What do you think? Can it have a maximum? Will you ever be able to find the highest y value?
No.
Why not?
Because it goes on forever.
Because it goes on forever. You'll never get there. So it can only have a what? Minimum. When it opens down,
It has a maximum.
can you ever go any higher than this?
No.
No. Can you get a minimum?
No.
No, because you'll never get there. It goes on forever. So it stops at a maximum. So when it opens down, it will always have a maximum. When it opens up, it will always have a minimum.
Basically,
Okay.
whatever the tip is pointing to.
Pardon?
Basically, whatever where they meet.
Right. So it has an imaginary line. Do you see any lines drawn on this graph anywhere? No. It has an imaginary line, though, that divides the parabola into what are called two symmetric halves. And that is called an axis of symmetry. You can't see it, but it's there. It is saying what happens on one side of this line is happening on the other side. You will find matching y values for opposite x values. Everything that happens on one side, the same behavior is happening on the other side. So it's going up on one side of that axis of symmetry, it's going up on the other side. It's equal distance from it, okay? So it's called those symmetric halves, and that line, that's imaginary. Notice it's dashed in our picture here. When we draw an axis of symmetry, which we're going to do, we're going to make it dashed because it's imaginary, okay? But we're going to show. Where does it go through? Look at the picture. Where's it going through?
Middle.
What's the middle called?
Or the origin.
The vertex. By the way, the vertex will not always be at the origin, unless it's the parent function. Then it will be at the origin. But if it's another quadratic function that's not the parent function, it's another member of the family, then its vertex is not going to be at the origin. So, but that place where the axis of symmetry is always going to have to go to the vertex, because that's where it makes its turn and its behavior goes the opposite direction, doesn't it? Okay. Questions so far on this side? These are all things you need to have an understanding of. Okay. Okay, let's go to the back side then. What are we doing back there? Okay. To identify, would you turn your calculators off for a bit here? But we're going to use them for a bit here. To identify if that's the second command, by the way. We're going to use them again, but just turn them off. To identify if a function is quadratic when it's given in equation form, you have to get the y alone. It has to get to y equals something so that we can tell if it's y equals ax squared plus bx plus c form. Okay? So get the y alone. Write the other side in standard form. You know what standard form is for a polynomial. You just reviewed that a couple of days ago on an assignment. X squareds would come first, the x's would be next, the constant would be last. And then determine if it is of the quadratic form y equals ax squared plus bx plus c. Where what? A can't equal 0. B can be equal 0? Yeah. Can C equal 0? Yes. Okay. Okay, let's look at number 1. Get y alone. What are we going to do to get y alone? Subtract 6x. So we have y by itself now, and what's the other side read?
Negative 14 plus negative 6x.
Says put the other side in standard form. Is that in standard form? Negative 14 plus negative 6x?
So,
No, so let's get it in standard form. The negative 6x and the negative 14 need to trade places. How you feeling about this? You think this is quadratic? What do you think, Julie? Do you think this is quadratic? You know? No? Aurora says no? Why not? Or A would be equal to what in this one? What's missing?
There's no x squared.
There's no x squared, so that meant A is equal to 0. It wiped it out, didn't it? Okay, let's go to our graphing calculators. Turn back on. Once you go to those y equals, clear out what we have in there right now. Get out those other two. Clear them out. Type this in. See what happens. See if we get a parabola. What'd you get? What's this line doing? Can you describe something about its behavior? It's falling from left to right. So you're not going to have a graphing calculator when you're doing your homework though, and you're not going to want to graph them to check it out that way. Instead, you're going to have to say to yourself, you know what? I know that because the x squared term is missing, this can't be a parabola. So we would say for this one that it is not quadratic, and then we would state, because we're so smart, that A equals what?
0.
0. Yeah, that's how it turned out linear. The x squared term got wiped out, it got multiplied by 0 and it's gone, and now it made it into a linear function instead of a quadratic function. Okay? Questions? Okay, let's do one more of those. Get the y along. What are we going to do first? Add 2x squared to both sides. You guys agree?
No.
Can we read addition backwards?
No.
What?
Yes.
What can't we read backwards?
Subtraction.
Subtraction. This is addition here. So it's y plus 2x squared. Would adding 2x squared make it move? What are we going to do? Yeah, we got to subtract 2x squared. Y is now by itself, and it's a positive 1y. We don't have to worry about that. And then, we got 3x, take away 1, take away 2x squared. All right? Are any of those like terms? Can any of those be put together? Okay. But if we change it to add the opposite, why would I want to change it to add the opposite? I got to check to see if this is in what? Standard form. Is it?
No.
No. So let's change it to add the opposite so that they can trade places. Okay? So y equals, what should come first?
Negative 2x squared.
Negative 2x squared plus 3x
Plus negative 1.
plus negative 1. How are you feeling about this one? Do you think this one's quadratic?
Yes.
Okay, before you want the graphing calculator to show you a picture, and I want you to tell me something about this. What do you think? Is this, first of all, the parent function? What's the parent function?
Negative 2x.
No.
Yes.
Y equals x squared. Is this y equals x squared?
Yes. Not alone, but
No. It's got to be y equals x squared, period. Cleaned up. That's what it looks like. Can we clean this up to look like y equals x squared?
no.
No, you can't ditch that negative 2 in front of the x squared. And you can't ditch that 3x. And you can't ditch that negative 1. They got to stay there. They're part of this function. It's a member of the family. It's just not the parent. It has what kind of a, you know what, before you, since you're convinced that it's quadratic, that means we should be able to identify A, B, and C. Let's do that. What's A equal?
Negative 2.
Negative 2. What's B equal?
3.
3. And what's C equal?
Negative 1.
Okay, I want you to predict something about this parabola before you graph it. Predict something about this parabola.
It came up and
It's
down.
going to be a parabola. Awesome. What's a parabola look like, by the way? It's like, I call it U-shaped, yeah, I call it U-shaped. Okay, well, we know that the U-shaped graph
It's
can
gonna
do what?
have curve.
Can it open,
Yeah, open
can it
down.
open up, or it can open
Yeah.
down? That means, what do you think this one's gonna do?
Open down.
Open down. Oh, does that mean it would have a minimum or a maximum? It would have a maximum. Okay, go ahead, now you can graph it. Go to y equals, clear out that linear one you had in there. And put in, remember, what do you use for a negative key? Not the subtraction, but,
Over the to the left.
yeah, the key to the left of the enter. The key to the left of the enter is your negative key. So negative 2x squared plus 3x plus negative 1 or subtract 1. And let's see if it really does do what you
I don't think
predict.
my calculator is supposed to do this.
You don't, huh? What's it doing? Why, looky at that. That is definitely not a quadratic function. I wonder what you did. Negative 2x to the negative 1 power. You have now explored what happens when you take it to a negative power. Or that negative, you must be listening to be taught or something and just did what
I
I
think I
said.
actually pressed the negative x over here.
Does it have the behavior we predicted?
Yes.
Okay. Okay. Does it have a maximum?
Yes.
Does it have a high point?
Yes.
Called a what again? What's that point? Vertex? Okay. And is it 0 this time? No. Not, is it? What's the one that's going to have 0 as its maximum or its minimum?
The parents.
The parent. And all the other, kids don't have that. They have a different maximum or minimum. So let's just draw. Where would the axis of symmetry go through? Even though it's not showing in here, where would it go through?
Little.
The middle. What's the middle?
The vertex.
The vertex. So we got this axis of symmetry that says, you know what, whatever's happening on one side of that is happening on the other side. Okay. At some point, you will learn how to make the graphing calculator draw that axis of symmetry. Not today. Anybody have questions on identifying if an equation represents a quadratic function without using a graphing calculator? Now, did you notice that to use a graphing calculator, we always have to get y alone, don't we? You can't do these any other way, so that's why we just keep getting y alone too. Okay, let's go then. What happens if we have a table of values, or in other words, a set of ordered pairs, and we have to decide if it represents a quadratic function or not. What we have to look for is a constant I think that's how I want to state it. Oh, okay, no, I'm wrong. Erase that. Erase that. I'm talking linear now, and I'm going back to linear. We're in quadratics now. A common second difference in y. It can't be a first difference, it has to be a second. If it's a common first difference, now we have a linear function. If it's a common second difference, then we have a quadratic. And if you have to go even further than that, then we're getting into some other families, okay? When there is a constant change in x. So we want a constant change right away in the x's, but then we're going to look for a second constant change, or a second common difference in the y's. Okay, so let's look at our table here. We have x equals -4, -3, -2, -1, and 0. Tell me, does x have a constant change?
Yes.
What's it doing? As it goes from this one to this one, what's it do?
It's adding.
It's adding 1. Does that happen all the way across?
Yes.
Yep, go ahead and do this then. This is how you would show your work. Does x, first of all, have a constant change? It does, of +1. Now we're going to look for what happens in the y's. So to get from the first y to the second y, 39 to 18, what are you going to do? 15? I don't think so.
minus 11.
No, look for something that you would add or subtract. No multiplying or dividing. Subtracting 21? Yeah. In other words, if you take 39, take away 18, isn't it 21? Yeah, so it goes down 21.
Then it goes down to 15.
Then it goes down 15. From 18 to 3, it is going down 15.
Minus 9.
From 3 to negative 6, it went down 9. And from negative 6 to negative 9, it goes down 3. Yeah, so negative 3. Okay, that's what we call the first difference. The first difference in y. Is it common, first of all? Did we get the same number all the way across? No, we didn't. If we had, we would stop right here and say, this is not quadratic, this is linear. Because linear is the first degree. First common difference. But it's not linear. We just proved it right here. So now we're going to do, and we're going to say, to get from negative 21 to negative 15, what do you got to do, Faith? 21 below, now it's 15 below. What happened?
You had 6 degrees.
Oh, Cody, is your name Faith now? Did she pass it to you? Did you, Faith? Sure, okay. Cody, what?
It's adding 6 degrees.
Adding 6. Okay. Go ahead and complete it the rest of the way across. To get from negative, on your own, to get from negative 15 to negative 9, to get from negative 9 to negative 3.
You subtract
So think of it like temperatures. 21 below up, the next hour that they measured is 15 below. Did it go up or down?
Up.
They went up in temperature, up 6 degrees, so it would be a plus 6. Okay? What is it from negative 15 to negative 9?
Negative 6.
From negative 6, did it go down 6?
Positive 6.
It went up 6 again. How about from 9 below to 3 below? It went up 6. So now we're going to say this is we just found the second difference in y. That's what we just were doing here. We're finding the second difference. So we did it first and it wasn't common. And then we moved down and found the second difference. And now we can say, is this quadratic?
Yes.
Because
Found the second difference.
it has a common second difference. Yeah, so let's say, is quadratic. Quadratic. Learn how to spell right here now. Is quadratic because it has a second difference of 6. That's how we can say it, because it was the same all the way across. It has a common difference of 6, so we can say it has a second difference of 6. So if we knew what the equation for this was, what would we expect would happen on the graph? If I told you right now, here's the equation of this table, what would you expect after I tell you what to put the equation to put in? What would you expect this graph to do?
To have
Pardon?
a minimum.
Okay, now, we don't really know right now just by looking at the points and not knowing the equation whether it would open up or down. But we know it would not be what kind of a graph? Linear. We know it would be what?
Quadratic.
It would be a parabola.
Parallel.
No, a parabola. It's going to be a parabola. We just don't know which direction it's open right now. We don't know that. We don't have enough information right now. But we know it will be a parabola on the graph. Now, we could put these points into lists, and we could ask them to make an equation for it, and we would find out. But we're not going to take the time to do that, okay? Right now. So go ahead, if your calculator hasn't turned itself off, or you hadn't turned it off, turn it off, return to the suitcase.